Welcome to my pre-algebra class. We're on chapter 10, section 10, and we're going to be working with square roots. A square root of a number is that number times itself that equals the number under the radical sign. So if I have the square root of 16, I'm looking for what number times itself makes 16. And it would be 4, since 4 times 4 makes 16. This is called the radical sign. A positive square root is an example. This is number 3. The positive square root of 64 is 8. If I want the negative square root, it's the negative sign in front of the square root. So that would be negative 8. The square root of a negative number does not exist right now. You'll see that later on with the imaginary numbers, because if I try to take the square root of a negative number, like you think it's going to be negative 6, if I multiply it by negative 6, I get positive 36. So right now there's no way to do it. Perfect squares, you should know them up to 100. So the perfect squares, 1 times 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared is 100. If we have under the radical a number that's not a perfect square, we have to use a table or calculators for an approximation. These kinds of numbers are called irrational numbers. So for the square root of 2, I would put 2, press the square root key, and I see my answer is a non-terminating, non-repeating decimal, and they might ask me to approximate it to the nearest tenth, and I would write 1.4 down. So we're ready to start the assignment. You need your paper headed. Your book's open to page 477. And have your calculator handy. So the directions for 1 through 40, number 2, is to find each square root. So we have the negative square root of 4. 2 times 2 makes 4, so it'd be negative 2. Number 4, these you should know without using a calculator. The negative square root of 81, 9 times 9 makes 81, so that would be negative 9. Number 6, the square root of 12,100. You can use your calculator on that. So you take 12100, press the square root key, and it's 110. So 110 times 110 makes 12,100. Number 8, you have the negative square root of 4 over 81. Use 2 lines for fractions. I want the answer as a fraction. This is the same as the square root of 4 over the square root of 81 negative. So it'd be negative 2, because 2 times 2 makes 4, and 9, because 9 times 9 makes 81. So your answer is negative 2/9. Leave it in fraction form. Number 10, we have the square root of 6.25. Again, you can use your calculator. 6.25, take the square root of that, it's 2.5. (11) through 14, use the table on 480 or a calculator. Approximate each square root to the nearest thousands. So number 12, we want the square root of 50. So we're going to put in 50, hit the radical key, and they want it to the nearest thousands. So 1's in the thousands place. There's a 0 after it, so it's going to be 7.071. Number 14, also to the nearest thousands. Put in 131. Take the square root of that. And to the nearest thousands, the 5's in the thousands place, the 5 after it will make it go up to 6. So our answer, remember, it was negative. is negative 11.446. 15 through 22, find the exact square root if possible, otherwise approximate the square root to the nearest thousands. Number 16, the square root of 40. That is not a perfect square, so enter 40 into your calculator, the square root key. To the nearest thousands, there's the 4 in the thousands place. The 5 will make it go up to a 5. So our answer will be 6.325. Number 18, if it's given as a fraction, leave it as a fraction. Square root of 1 over 25, the square root of 1 over the square root of 25. Square root of 1 is 1, the square root of 25, that's a perfect square, is 5. So our answer is 1/5. Number 20, the square root of 225, that is a perfect square. If you don't know it, put it into your calculator, get the square root key, that's 15 times 15. So that equals 15. Number 22, you have the negative square root of 84. 84 is not a perfect square. Entering it into the calculator, we get this number. 5's in the thousands, 1 is less than 5, so we'll keep it at 5. So our answer is negative 9.165. Number 24, find each answer, if necessary, round to the nearest thousands. 24 has the square root of 36 plus 64. So we have to add what's under the radical. 36 plus 64 gives us 100. 100 is a perfect square. It's 10, square root of it is 10, because 10 times 10 makes 100. Number 26, we have the square root of 24 plus the square root of 25. Now we cannot add those together. There's no rule that says we can do that. So I have to find the square root of 24. And it's irrational, so I'm going to round it to the nearest thousand. So that would be, the 8 is going to become a 9. So that's 4.899 plus the square root of 25, which is 5. It's a perfect square. Adding that together, I get 9.899. 28, I have the square root of 9 times the square root of 16. That's the square root of 9 times 16 is 144, which is a perfect square. That's 12 times 12, if you remember your 12s tables. Problem number 30. Using the table of squares and square roots on 480, find a number between 5,000 and 5,100 that's a perfect square. Okay, you're looking at your table on page 480. Turn there now. Go down the list of squares until you see a perfect square that's between 5,000 and 5,100. So it'd be in the second set of perfect squares, and there's 4,900, and then there's, that won't work, but the next one will. 5,041 is between 5,000 and 5,100, and that's a perfect square. Its square root is 71. Number 32, the symbol, the radical, is read the square root of, because evaluating the square root of x gives you the length of the side of a square with area x. Number 32, the area of a square is 45 feet squared. Approximate its perimeter to the nearest tenth of a foot. If the area equals 45 feet squared, that's the area equals s squared. So 45 equals s squared. If I want to find out the length of one side, I have to take the square root of that number. So s equals the square root of 45. So I'm going to take 45 and find its square root. And they said to the nearest tenth, so it'd be 6.7 for one side, equals the length of one side. So here I have a square whose one side is 6.7, and remember, all the sides are the same, and the easiest way to find the perimeter is just to take 4 times the side, so 4 times 6.7 will equal 26.8 feet. Problem number 33 through 40, find each answer mentally. And they're using perfect squares up there, the square roots of perfect squares, so you should do those without too much work. So 34, I'm going to write the problem down. 29 minus the square root of 49. So that's 29 minus 7, which is 22. 36, you have the square root of 100 plus 87, which would be 10 plus 87, which makes 97. 38, you have the square root of 16 over 8. The square root of 16 is 4 over 8 equals 1/2. And 40, the square root of 1 plus the square root of 64 minus the square root of 9. That would be 1 plus 8 minus 3. That's 9 minus 3, which makes 6. That concludes the evens. Be sure you check at the back of the book for the answers to the odds.